Okay, let's dive right into this. I want you to picture a scenario that is honestly every single developer's worst nightmare. It's the end of a long, exhausting day. You finally push your code to GitHub, you close your laptop, and you head to the kitchen to grab a well-deserved snack. But then, 5 minutes later, you get an email from Amazon. You open the email, and your stomach just completely drops. Your AWS bill just spiked by $20,000 in 5 minutes. Why? How does that even happen? Well, it's because you left a tiny, seemingly harmless string of text in your repository. You hard-coded your AWS Access Keys into your script, and a malicious bot just scraped them, literally stealing your identity to spin up hundreds of massive, expensive EC2 instances to mine cryptocurrency entirely on your dime. So let me show you how to actually give your applications secure access to AWS without ever touching a secret key. You see, when you, as a human being, log into the AWS Management Console, you use a standard password. But when your code needs to talk to AWS, like say a backend app trying to read a file from an S3 bucket, it relies on programmatic access keys. Now, these consist of two parts, an access key ID and a secret access key. The fatal mistake developers make is treating these keys like permanent passwords and just pasting them directly into their application code. If that code gets pushed to a public repository or even shared accidentally in a private Slack channel, your entire AWS account is completely compromised. Plus, because access keys are static, if you don't actively rotate them, they literally live forever. Which brings us to the absolute golden rule for an AWS developer. And it is this: applications should never store AWS credentials directly. Never. Let that sink in. So naturally, you might be wondering, how does an application get permission then? We know it needs access to function, but we just established we absolutely cannot give it a permanent key. Well, this is where we pivot from a potential disaster to the smart, highly secure solution. You use IAM roles. Now, let's slow down here for a second to look at this comparison, because grasping this exact difference is absolutely essential. Think of an IAM user like an employee with a permanent ID badge. It belongs uniquely to them, and it works every single day until it's officially revoked by HR. But think of an IAM role more like a temporary contractor hat. A role does not have a permanent password, and it certainly does not have long-term access keys associated with it. It is simply an identity that a trusted entity can assume just to obtain temporary, short-lived security credentials for a specific job. Here is exactly how this works under the hood. Let's take an AWS Lambda function that needs to write data to a DynamoDB table. You don't bake a key into the deployment package. No way. Instead, you create an IAM role, specifically an execution role, and attach it to the function. Now here's where this gets really interesting. You don't just give the role a permissions policy to talk to DynamoDB. You must also configure a trust policy. The trust policy explicitly states who is allowed to wear the hat. In this case, you literally tell AWS, I trust the Lambda service to assume this role. Think about that for a second. Your code never handles the credentials directly. The AWS compute environment running your code assumes the identity entirely on your behalf. Now, pay close attention here, because this is where people mess up. They successfully attach the role, but then they sit there trying to figure out how to manually extract or pass the credentials from the role into their actual Python or Node.js script. You don't. Let's move to the next step and see how this builds out entirely automatically. Imagine this. Your Lambda function spins up. Because it has an execution role attached, the AWS environment automatically requests the temporary security credentials and injects them securely into the local environment, completely behind the scenes. Your AWS SDK, like Boto3 for Python, for example, is incredibly smart. When you write a single line of code to put an item in DynamoDB, you don't specify any credentials at all. The SDK automatically searches the local environment, finds those temporary keys, signs the API request, and executes it. And this brilliantly illustrates a very simple, everyday concept. It is exactly like staying at a hotel. Think about it. You don't bring your own permanent deadbolt lock from home and attach it to your hotel room door, right? The front desk gives you a temporary digital key card. When you check out at the end of your stay, the card simply expires. If you happen to lose it down by the pool, the hotel just deactivates it instantly with zero risk to the actual building. That is exactly what an IAM role does for your compute resources. Now, watch out for this exact trap in your exams and out there in real-world production environments. Let's say an application running on an EC2 instance needs to access S3. A developer creates an IAM user, generates long-term access keys, and places them in a shared credentials file right there on the server. Sure, the application works perfectly, but this is a critical security failure. If a bad actor compromises that EC2 instance, they can simply copy that file and use those permanent keys from anywhere in the world. As a responsible AWS developer, you must delete that user, delete those keys, create an IAM role with an S3 access policy, and attach it directly to the EC2 server. The AWS SDK will automatically rotate the temporary credentials in the background. You literally never manage a single key.
All right, let's lock this down. Here are your 3 rapid takeaways for this explainer. Number 1, never hardcode access keys in your application or store them on your compute instances, because leaked keys lead to instant account compromise. Number 2, use IAM roles for applications running on EC2 or Lambda to grant your code temporary automatically rotating security credentials. And number 3, remember that an IAM role requires both a permissions policy to define what actions are allowed and a trust policy to define which service or account is allowed to assume it.
One final warning before we wrap up. If you ever accidentally commit an access key to GitHub, do not just delete the commit and pretend it didn't happen. The bots have already scraped it. Immediately go into the AWS console, cut all API connections, and delete the key forever. So think about your own projects for a moment. Are you absolutely sure there are no hard-coded keys hiding in your code right now?